Welcome back to the deep dive. I have to admit, looking at the stack of notes for today, I'm feeling a little bit anxious.
Anxious. That's not the usual vibe here. It's usually curiosity.
Well, usually we're learning about how things work in theory, but today we're talking about a tool that, if I'm reading this technical guide correctly, has the power to absolutely ruin my week, my month, and possibly my career.
Laughing slightly.
Oh, yeah.
We are back in the world of database management. We're looking at that CRU acronym again: create, read, update, delete. But we're zooming in specifically on the U, the update.
The update. Ah, yes. The surgical knife of the database world.
Exactly. And the source material, this guide called update.md, makes it sound less like a feature and more like a loaded weapon.
That is a healthy fear to have. You know, when we talked about C, creating data that feels productive, you're making something new.
Right.
When we talked about R, reading data, running those select queries, that felt safe. You're just if you mess up a select query, the worst thing that happens is, you get an error message to the wrong list. No harm done.
But the update is where things get real. The source defines the mission here as understanding how to modify existing data. And that word existing is doing a lot of heavy lifting. You are taking reality, a customer's address, a product's price, an inventory count, and you are rewriting it.
And once you rewrite it, the old version is just gone.
Poof, gone.
See, that's the part that stresses me out. We live in this world of undo. I make a typo in a document, I hit Ctrl-Z.
Right.
I accidentally delete a photo, I pull it out of the trash can. I send an email, I regret, I have 10 seconds to unsend it.
Yeah.
We are trained to believe that digital actions are reversible.
And SQL is here to tell you that is a law.
Great.
The source material has this warning just plastered all over it. Once UPDate is executed, you can't undo the operation. The database just assumes that if you type the command, you meant it. It doesn't ask, are you sure? It doesn't save a backup copy for you. It just overwrites the bits on the hard drive.
So if the mission of this deep dive is to master the update command, I feel like the submission is how to not destroy the company database.
Precisely. It's all about precision. But before we get to the disaster scenarios, and we will get there, let's talk about why we even need this risk in the first place.
Right. Why not just keep everything static?
Because the world isn't static. I mean, if a database couldn't be updated, it would just be a history book. It would be an archive of what the world looked like on the day you created it. The update command is what lets the database stay in sync with reality. It's the bridge between a static record and a living system.
Okay, that makes sense. We need to be able to change a price if inflation hits, or change an address if someone moves. So let's look at the mechanics. How do we actually, construct this command? The notes mention a specific syntax.
It's surprisingly simple, which honestly is part of the danger. It reads almost like an English sentence. You start with update, and you name the table you want to modify. So update customer.
Okay, so we're in the customer's bucket.
Then you use the keyword set. This is the trigger. You say set column name is new value. For example, set email new address at gmail.com.
That seems straightforward. You name the table, you name the column, you give it the new value.
You can even do multiple columns at once. Set email is this and address that. It's very flexible.
But then I saw something in the notes that it confused me. It says you can use clauses like order by and limit in an update statement, but then it immediately says they are rare.
Oh, very rare.
That stopped me, because when we were learning about reading data, the select command, I used order by all the time. Show me the top 10 most expensive items. Show me customers alphabetically. It's super useful. Why is it rare here?
I just think about the intent.
Yeah.
Why do you use order by in a select statement? You use it for presentation.
Right, to see the data in a certain way.
But when you're updating data, you aren't presenting it. You are performing surgery. Do you really want to say update the first 10 customers alphabetically?
I mean, probably not.
Who are the first 10 alphabetically? The Aarons and the Abigails. Why would you want to change their data just because their names start with A?
That would be totally arbitrary.
Exactly. And database management hates arbitrary. If you use order by and limit in an update, you're saying, I want to change some records and I don't really care who they are, just grab the first few. That is almost never what you want in a business context. You want to update specific people or specific products. Identity matters more than order.
That clicks. Yeah, you wouldn't want to accidentally discount the wrong product just because it happened to be at the top of the list that morning.
Exactly. It creates unpredictability. And in this game, unpredictability is the enemy.
Speaking of predicting things, the source material throws out this little rhetorical challenge. It shows a query and asks, What do you think will be the result of the above query?
I love that the guide does that.
It felt like being back in school. Put your pencils down.
But it's a crucial habit. Because remember, there is no undo. So the only safety net you have is your own brain. You have to be the simulator.
The simulator.
You have to look at the code you just wrote, close your eyes, and just run it in your head. If I run this, I predict it will change exactly one row. Or, I predict it will change all the orders from 2022. If you cannot predict the result with 100% certainty, you do not touch that execute button.
So you have to visualize the blast radius before you drop the bomb.
That is a very vivid and very accurate analogy.
Well, let's talk about the blast radius then, because this brings us to the most dramatic part of the notes, the where clause.
Yes, the where clause, the hero of our story.
Or the villain, if you forget it. The notes point out a contradiction that I found really disturbing. It says the where clause is technically optional. The syntax works perfectly fine without it, but then it says it is used almost all the time.
That is the classic SQL foot gun.
A foot gun.
A feature designed in a way that makes it very easy to shoot yourself in the foot. Syntactically, the database is perfectly happy with a command like update customer status inactive. That's a valid sentence.
Well, wait. If I run that and I don't have a where clause,
then you haven't told the database which customers to update.
Sure.
So it updates all of them.
All of them.
Every single row. It starts at the top of the table and goes all the way to the bottom.
So if I'm trying to mark one customer as inactive because they stopped paying, and I forget the where clause.
You have just fired every single customer in your database. You've marked everyone as inactive. Your application stops working, nobody can log in, and your phone starts ringing off the hook.
And there is no undo.
No undo. You've just corrupted your entire data set in the time it took to click a mouse button.
That is nauseating, truly.
In the industry, we call that a resume-generating event.
Because you'll be out looking for a new job the next morning.
Exactly. It is the #1 nightmare of every junior database administrator. You stare at the screen, the blood drains from your face, and you realize you just overwrote everything.
So the where clause isn't just a filter, it's the safety lock.
It is the constraint. It tells the system, do not just apply this change blindly. Search for these specific rows first. Find the rows that match this condition, and only then apply the update.
The source material gives some advice on this. It says the where clause should uniquely identify the records to be updated.
Uniquely identify. That is the gold standard.
So saying where named John isn't good enough.
It's so risky. I mean, think about it. How many Johns are in a standard customer list?
Probably a lot.
Right. If you say, update John's address to this new place in London, and you have 50 Johns, you just moved 50 people to London. You corrupted 49 records to fix one.
So how do we get precise? The notes mention the primary key.
The primary key. This is the unique ID number assigned to every single row. Customer ID 10154. There is only one 1054 in the universe of your database.
So if I use the ID, I'm safe.
You're much, much safer. If you write where customer ID 1054, you know for a fact that the blast radius is exactly one row.
It really feels like the guide is just screaming, be careful, every other paragraph.
They really can't say it enough. You know, some database tools actually have a safe mode that prevents you from running an update without a where clause. It's like training wheels, because the mistake is so common and so devastating.
To make this a bit more concrete, the source suggests a practical exercise. It talks about the Chinook database.
Ah, yes, the Chinook database. It's a classic.
Is it?
It's the hello world of SQL data. It's a sample database that represents a digital media store. It has tables for artists, albums, customers, invoices. It's used in tutorials everywhere because it's so relatable.
And the guide suggests using a tool called dbeaver to actually run queries on it.
dbeaver is a great tool. It gives you a visual interface, but the key here is the psychological aspect of actually doing the exercise.
What do you mean?
You can read about the danger of the where clause. You can nod your head and say, yes, I will be careful. But until you sit in front of dbeaver, type out update, and feel that hesitation before you hit execute, you don't really get it.
It's the difference between reading a flight manual and sitting in the cockpit.
Exactly. And doing it on the Chinook database is like a flight simulator. If you mess up and rename every artist to Taylor Swift, nobody loses their real data. You just reset the file. It's a safe space to fail. And you should fail there so you don't fail when you're working on the real production database.
I like that. Break the toy database so you don't break the real one.
Exactly.
So we've covered the manual side, sitting at a computer, typing SQL commands, but the source material shifts gears here. It moves into the Python environment.
This is a crucial shift because, let's be honest, in the modern world, how often is a human being manually typing update commands?
I would assume not often.
Rarely. If you change your password on a website, there isn't some guy named Steve at headquarters typing update user's set password.
I would hope not. Steve would be very busy.
It's an application doing it. The code, often Python takes your input and talks to the database for you.
So how does the behavior change when we move from raw SQL to Python code?
The core logic is the same. You still need update, set, and where. But the feedback loop is different. The notes highlight a key technical nuance here. Update doesn't return records.
What does that mean exactly?
When you run a select statement, when you read data, the database sends back a package. Here are the rows you asked for. But update is an action, not a question.
So it's silent.
Mostly. The notes say it updates values in place. You send the command, the database does the work internally, and then it just says nothing. Or maybe it returns a number, like one row affected, but it doesn't show you the data.
That makes the no undo thing even scarier. You don't even see the result immediately.
You are flying on instruments. You just have to trust that your logic was sound.
So how do we actually send these commands in Python? The notes mention something called a cursor.
Yes. The cursor object.
I always found that name confusing. It's not like a mouse cursor.
No, not
Okay.
at all. Think of the cursor as a messenger. Or maybe a delivery driver.
The delivery driver. I like that.
Your Python code is in one building. The database is in a secure vault down the street. They don't speak directly. So you hire a cursor. You hand the SQL command to the cursor and say, go run this. The cursor drives to the database, executes the command, and comes back.
And the method we use to tell the driver what to do is execute.
Right. Cursor.execute. You put your SQL string inside that function, and again, the notes emphasize. You use this to update records based on the where clause. Even in Python, you cannot escape the where clause.
Now this brings us to a part of the guide that felt like a movie plot twist. We start talking about security, specifically untrusted data.
This is huge. If you are building any kind of app, this is probably the most dangerous part of the job.
And we define untrusted data. It sounds so paranoid.
In security, you have to be paranoid. Untrusted data is essentially anything that comes from the outside world. If you have a form on your website where a user types their name or their address, that input is untrusted.
Even if it's a loyal customer.
Even if it's your grandma, you cannot assume the input is safe. Users make typos, they use weird characters that might confuse the code, and sometimes they are malicious.
This is where we get into SQL injection, right?
Exactly. Imagine you have code that says update user's set name, user input. If a hacker types in a real name, fine. But what if they type in a piece of SQL code?
Code inside the name box.
Yes, they could type something that closes your command and starts a new one. They could trick your Python cursor into running a command that deletes the entire table or, grants them admin access.
That is terrifying. So the box asking for my name is actually a potential backdoor into the entire database.
If you don't handle it correctly, yes.
So how do we fix it? The source mentions a parameterized query.
This is the shield. The solution found in the source is simple but so powerful. You use a placeholder.
Yeah.
Specifically the question mark symbol.
Just a question mark.
Just a question mark. So in your Python code, you don't stick the user's input directly into the string. You write update user set name, where ID, user.
And then what happens?
Then when you call cursor.execute, you send that string with the question marks, and you hand over the user's data as a separate package.
Why does separating them make it safe?
Think of it like airport security.
Okay.
The SQL string, the command, is the flight plan. It's approved. The user data is the luggage. By using parameterized queries, you are putting the luggage through the X-ray machine. The database looks at that question mark and says, okay, whatever comes in this slot is just data. It is luggage. I will store it, but I will not let it fly the plane.
So even if a hacker types in malicious codes, the database just treats it as text.
Exactly. It just saves a user whose name happens to be a weird string of code. It never executes it.
That is a relief. So the notes are basically saying, use the question mark to handle untrusted data safely.
It's the industry standard. I mean, if you are gluing strings together to build your queries, you are leaving the door unlocked.
It really seems like safety first is the recurring theme of this entire deep dive. Whether it's the where clause preventing you from overwriting the whole table, or the parameterized query preventing hackers from hijacking your system.
It really is. The update command is a power tool. Think of it like a chainsaw. It's incredibly efficient at what it does. But if you don't wear your safety goggles and you don't use the safety guard, you are going to get hurt.
So let's step back and look at the map of what we've covered. We started with the basic definition, the U in CR Read.
Right. The ability to modify existing data. The thing that makes a database a living reflection of the real world.
But with great power comes, well, no undo button.
No undo button. That is the mantra.
We looked at the syntax, update, set. And we had that interesting detour about why order by is so rare. Between order and chaos.
The only thing stopping you from creating a database where everyone is named John?
I'm going to have nightmares about that. And finally, we looked at how this all works in Python. The use of cursors to deliver the message, and the absolute necessity of using those question mark placeholders to handle untrusted data.
It's a journey from how do I write this command to how do I use this command without destroying the company?
You know, it really makes you think. We spend so much of our digital lives just cruising on autopilot. We click accept, we hit send, we rely on the cloud to save us.
We assume technology is forgiving.
But the database UP date, that is one of the few places left in modern computing where you have to be absolutely 100% certain before you act. It's a reminder that underneath all the shiny interfaces, there's machinery that is strict, permanent, and unforgiving.
It's a sobering thought. When you hit execute, you are carving that data into stone.
So for everyone listening, stay curious, build cool things, but for the love of data, watch that wear clause.
Please do.
Thanks for diving in with us. We'll see you on the next deep dive.